And welcome. All right. So start off here with part 2 here, and look at this example. So we have a car moving with initial velocity of 5 miles per hour and accelerates at a rate of 2.4 t miles per hour per second for 8 seconds. So for part A, it's asking us how fast is the car going when the 8 seconds are up. So what we want to think about here is, well, we want to accumulate all my acceleration. That's going to give me my velocity. So what does that mean? That means that my velocity, okay, at any given time, well, that means it's kind of like the last one where we had our position was based off of our initial position and our displacement. Our final velocity is going to be based off of our initial velocity of 5 miles per hour. And then we're going to accumulate, okay, plus we're going to accumulate from 0 to some point t my acceleration. And we'll say a of u du. And that's what v of t is going to be. We got to make sure this makes sense. Okay, so t is going to be measured in seconds, and they say this acceleration is miles per hour per second. So if we have miles per hour per second times seconds, okay, that will go ahead and give us miles per hour added to the miles per hour that we already have here. Okay, so we will end up with miles per hour, which is what we're looking for. Okay, so let's go ahead and do that. All right, so if I go ahead and get my velocity, all right, it's going to be equal to 5. That's the integral. From 0, we're going to do the 8 seconds of a, which is 2.4 u du. Now again, the reason why I'm using a u instead of a t is because technically 8 is our time, and we made this new function up for velocity. And so all I did was change the variable so t wouldn't be used twice. So when I plug this in, I do take 5 plus, okay, 2.4. So again, raise my power up 1 and divide by that power. I get 1.2 u squared from 0 to 8. Okay, I plug that 8 in there, and I get 5 plus 76.8 minus 0. All right, and that's going to equal 81.8 miles per hour. So I started off with the initial velocity of 5 miles per hour, and then 8 seconds later, I'm going 81.8 miles per hour. Bam. That's hecka fast. So let's talk about part B. Okay. So I'm going to go back over here and say, well, how far did that car travel during those 8 seconds? Okay. So when I'm talking about part B, I'm going to go to the next slide here to talk about part B. And it's asking how far did the car travel during those 8 seconds? Well, now it's talking about distance. And it's actually talking about, that could even be called total distance. So we have to remember, well, what does that look like? Well, total distance, I'll call it TD, is going to be equal to the integral from 0 to some time of the absolute value of my velocity function. Oh, technically a u again, du. But I don't know my velocity function. I know my acceleration function. Okay, and so again, this is where we're going to use the indefinite integral to help us find out our velocity function. So I know that my velocity function can be equal to the integral of a of t dt. Again, notice no integration there. No limits of integration. So when I do that, I do the antiderivative. Let me do this here. Is equal to the integral then of 2.4t dt. I go ahead and I plug in, and I find out, well, this is v of t is equal to that 1.2 t squared plus a c. Well, how can I figure out what that c is? Well, again, they give us my initial velocity of 5 miles per hour. So I know that at time is equal to 0, my velocity is 5. So that's going to be 1.20 squared plus c, so 5 is equal to c. So putting that all together, my final velocity function is equal to 1.2 t squared plus 5. Oh, okay, so then I come back over here to my total distance. And I go ahead and plug that in. Integral from 0 to 8, 1.2 u squared plus a 5, absolute value from du. So again, what you have to do is a little bit of analysis here. Does the absolute value, is it necessary? And I look at this and I start thinking to self, okay, so I'm starting up at 5 and I keep adding in, well, all this is positive. Will it ever go and be negative? Answer is no. It will never be negative. So do I need the absolute values? No. Okay, 0 to 8 of 1.2 u squared plus a 5 du. I take my antiderivative, raise it up a power. So it'll be in divide by that new one, which is 3. So it's 0.4 u cubed plus a 5u evaluated from 0 to 8. And with the help of a calculator, I get 244.8 minus 0, which is equal to a 244.8. But this is then where I have to check myself. So here's my answer, and I have to think, okay, well, I now need to check my units. Did it make sense? And I realized that my velocity was done in miles per hour. But again, now I'm in seconds. So what did I end up getting? I got miles per hour times seconds. Oh. So I need to find out how many hours are in a second in order to get, how many seconds are an hour in order to cancel everything out. Okay? So, because if you look at just the unit analysis, I have miles per hour times seconds. And so that's what I have with this part here. Okay? So then what do I need to do? I need to multiply all of this by, in 1 hour, there are 3,600 seconds. And when those units cancel out, I'm just left with miles. So I take my 244.8 times 1 over 3,600, and I get 0.068 miles. So that's one fast car that in 0.068 miles, it goes up from from 5 miles per hour to 81 point whatever miles per hour. Dang, right? That's zipping pretty quick. All right. A good problem. A good problem. Okay? And it takes the in-depth understanding that you need to have in order to do these types of problems. You need to put yourself inside the problem and look at what you're given and find out what you need to go. All right? Much like this next example. Okay, so from 1970 to 1980, the rate of potato consumption in a particular country, CFT, was 2.2 plus 1.1 to the T millions of bushels per year, with T being years since the beginning of 1970. How many bushels were consumed from the beginning of 1972 to the end of 1973? Whew. So again, they're giving me some type of rate here of how much is being consumed. And they're asking me how much was totally consumed. So I want to, how much was eaten up. So that's going to require that integration part because that's how I sum things up. So when I sum things up, okay, so I want the integration part of this 2.2 plus 1.1 to the T, millions of bushels, so DT. This is in millions of bushels per year, and they want me to do this over years, so when I get done, millions of bushels per year times years, bingo. That'll get me what I'm looking for millions of bushels per year. That's what I want at the end. All right, cool. From 1972 to 1973. All right. So this is something that you can be like, well, how do I do this? So I want T is beginning years since the beginning of 1970. Okay, so when T is 0, okay, that is 1970. And when T equals 1, that is the beginning of 1971. And when T equals 2, that's the beginning of 1972. Well, the beginning of 1972 could also be classified as the end of 1971, right? So how am I going to get these years? So when I evaluate this a little bit more, T equals 3 is the beginning of 1973, and T equals 4 is the beginning of 1974. Okay, and they want from the beginning of 1972, so that's an easy part. That's going to be T equals 2 to the end of 1973. So again, you have to read the problem and realize it's not going to just be to 3 because that represents the beginning of 1973. It wants the end of 1973, which is the same as the beginning of 1974. So when I go over here, I'm actually going to plug in 4. All right, so this is where you're going to get your calculator out. You're going to plug it in. I'm going to get mine out. I'm going to show you, just give you a reminder of how to plug this in, and we'll take care of it from there. All right, so I brought my calculator up now. And now what I'm going to show you is I put my function in there, 2.2 plus 1.1 to the x. I'll give you guys a second to go ahead and put that in your calculator, or if you need more time, pause me. And what I need to do is I want to integrate that from 2 to 4. So I'm going to go over here again to second, and I'm going to quit out of here. Oops, second, quit. There we go. And this is where I go up over here and I hit math. And I'm going to do the number 9. And then I'm going from 2 to 4. And remember, I hit vars. I move over to y vars. I choose the function. I choose y1. And I screwed over. And I say dx. And I hit the magic enter button. And it tells me 7.066. Again, I want 3 decimal places. So I come back over here. And I find out that this is equal to 7.066. And don't forget to put in the units, millions of bushels, not per bushels, of bushels, of potatoes. Okay. Consumed from the beginning of 1972 to the end of 1973. That's a lot of potatoes. What I want you guys to get from all of this, okay, this is what I want you guys to get from all of this, is that when you integrate a rate, you get the stuff. Well, what does that mean? Well, when I integrated miles per hour, I got miles. When I integrated bushels per year, I got bushels. When I integrate, I don't know, feet per second, I'm going to get feet. When I integrate people per year, I'm going to get people. When I integrate people per minute, I'm going to get people. Okay? As long as my time units match up. When I integrate a rate, I'm going to get the stuff. Okay? When you integrate the rate, you're going to get the stuff. It's important to know, because if they're asking you for the stuff, you're going to integrate. And the reason why it's important to know is because you have to realize that in this test that you guys are going to take, you're only going to have two options. Either you're going to take a derivative or you're going to take an integral. And you need to know which one to take. If they're asking for a rate, probably going to take a derivative. If they're asking for the stuff, probably going to integrate. Okay? Whew. All right. Here's your homework. There it is. Looks like a lot. It's not too bad. All right. You guys can do this. And don't forget, after this section, there's a quiz in a couple of days, so be mindful of that. See you guys on the flip side.